Hello, everyone, and I am going to begin our discussion on our first section, and it will be related to complex numbers, which is covering section 1.5. I will go through, and there will be two parts to this section, so let's begin the process. What will you learn? What are our objectives here? Our objectives will be to add and subtract complex numbers, divide complex numbers, multiply complex numbers, simplify square root of negative numbers, talk about the imaginary unit of I and its properties, use complex numbers to solve applications involving electrical engineering. So let's talk about complex numbers. The imaginary unit I, okay, and so we're literally talking about the letter I here, the imaginary unit I, is basically involving the real number system, but yet its lack of symmetry in the definition of the roots and real numbers. So what we need to recall is that we have defined even roots only for non-negative numbers, but we have defined our roots for both positive and negative numbers. So mainly what we're going to be looking at is what mainly we will master is that if x is equal to the square root of a, and x is equal to the negative square root of a, that's given that a is positive, but no real solutions if a is negative, okay? So that's how we've previously been discussing. But now we're gonna look at the scenario of an imaginary unit, which of I, which is defined as I is gonna be equal to the square root of -1, okay? In other words, I has the property that its square is -1. So that leads us to understand that I squared is equal to a -1. This allows us to immediately define square roots of negative numbers by the imaginary unit of I. So we're going to put this into practice. So let's talk about us to define square roots of negative numbers in general. So if a again is positive, so the square root of a negative a is going to turn into a, square root of a. So note that by definition that the logical extension here is that it's going to be turned into a negative a. So let's look at some models to assist us with this process. All right, so we're going to look at these four models to demonstrate complex numbers. And let's recall of what the imaginary unit I says. So we need to make reference that the square root of -1 is equal to I, okay? So please make sure you take these notes. And so you will have these as a reference. And also we need to make note that I square is equal to -1, okay? All right, so let's begin the process of let's evaluate and look at the square root of -16. So right away, what we're gonna pull out of that is the square root of -1 times the square root of 16. So that allows me a place to understand that the square root of -1, what would that convert to? It'll convert to I. And then we also understand the square root of 16 is simply 4. So our final answer here, we always state the number first, 4, and then the imaginary number I. So there we have it, 4I, final answer there. Okay. Same process with B model, but we're going to manually break down the square root of 8. So with the square root of -8, we know we're going to pull out the square root of -1. Let's pull the negative out. Then let's break down the square root of 8. So that'll become the square root of 4 times the square root of 2, okay? So once again, I will rename the square root of -1 as the imaginary unit I. Square root of 4 will drop down to 2, right? Square root of 4 is 2, and that leaves me with the square root of 2. So there, what do I understand to become that would be 2I times the square root of 2, final answer. So hopefully you see the process is not too bad here in this process. But now let's go further and let's evaluate what does it mean by I cubed versus I to the fourth? So let's do that breakdown, okay? So with I cubed, versus I to the fourth, so with I cubed, here's what we're simply stating. I can already pull out an I cube, I can pull out I square, right? And then I have left is an I, all right? So right away, what do we understand I square? It will break down to turn into a -1 times, and there again, I still have I, all right? And so there, we realize from -1 times I, that result will become a -I, okay? That's that process. Now with I to the fourth, its breakdown will be I square times I square, okay? And from that place, we know I square is equal to -1. Once again, another I square will become a -1. So -1 times -1 will give me that result of a +1. So that is the difference approach that you will make when you have I and you have to simplify, given that it's just showing it with an exponent, I cubed versus I4. So let's look at our D model where we show -I square. How will we approach here? So now in this process, there is an imaginary number, which we know there it is, that -1. So we need to identify -1 square times, and then I break down I square, okay? So what can we realize here? We know I square will again break down to be a -1 times -1 square, -1 times -1, a +1. So that final answer will turn into a -1. So this is truly testing you to understand the negative rules. Please have handy a scientific calculator. A TI 83, 84 version would be awesome with this. That will compute it for you in that essence. So you are able to use that as a technology to assist you with the calculations. Okay, our next part we're going to talk about is the powers of I. There are powers of I following a pattern that repeats with every fourth power, okay? So mainly, here is the table that we're going to use to assist us with the power of I, and this table will need to be used in order to compute problems involving the powers of I. So here we show going through the exponent I to the 1 power, of course that's I squared is equal to a -1. I cubed, which we just computed, that became a -I, and I to the fourth, we just computed, became to a +1. So after that place, we then began the properties of using I 4 to the n plus 1, I 4 to the n plus 2, I 4 to the n plus 3, I 4 to the n equals 1. So given this scenario, this will allow us to see if our answer will become an I, a -1, a -I, or 1. So let's put this into practice using the powers of I to compute a few example models. So let's get ready to review those models. All right, so here we show the types, the powers of I's, and there again, as we go through what I just have charted here, I raised to the 1 power is I to the second is -1. This tilde means it goes up as an exponent. I to the third, it goes up as an exponent, -1. I to the fourth, 1. I to the negative, I to the 4 plus 1 equals I raised to the 4n plus 2 is a -1. I raised to the 4n plus 3 will come out as a -I, and I to the 4n equals 1. So when we identify these powers of I's, let's look at our first model. How can we break down I to the 9th? So since we know that I to the 9th can be broken down as 4 times 2 plus 1, and so we now know the n is 2, that will give us I to the 9th. So in this scenario, we realize that this fits the type of being I to the 4n plus 1, because the remainder, when we take, basically divide 4 into 9, we have 1 left over, so the remainder, which is 1. So that leaves us here to plus 1. So we know our end result will be equal to I. That is how we can identify the powers of I. So that's how that will be our final answer there with that breakdown. That's the pattern, the power that it fits. All right, so let's try B model. I to the 28. So here, again, applying 4. We know 4 times 7 equals 28. So therefore, we realize here, what is the pattern? The 7 is an n. So we just have 4n. What's the computation for I to the 4n? The I raised to the 4n is 1. So our final answer here is simply 1. That's the process. And then same process with 102. Let's try it. I 102, we could do 4 times 25, because that will make 100. So 100, what's left over would be plus 2. So therefore, from that process, I'm able to see I raised to the 4n plus 2. So given that ratio here, what we can understand from that type of power, 4n plus 2, that result will become a -1. So take a moment, process this, practice this again, rewrite it again, and try to see the scenario, because it's just working with the 4 unit of powers and identifying the level of I. All right, well, this will conclude part 1. We will next work with the operations of complex numbers. Stay tuned, take care, have a great one. Goodbye.